Hello and welcome. This is week 15 in the Bootstrap method. Uh, let's solve the single most terrifying problem in business analytics, the lonely sample. Look at this plot. This is your reality. You ran one A/B test. You have 1 month of customer churn data. This dataset is skewed, messy, and finite. But your stakeholders don't just want the average. They want to know the risk. Is this revenue increase real or just luck? What is the worst case scenario? Can I trust this number? To answer this, classical statistics forces you to assume your data follows a perfect bell curve. But in business revenue, viral hits, insurance claims data, it's rarely normal. It is chaotic. So how do we measure uncertainty without making dangerous assumptions? We use the bootstrap. So let's visualize the logic. We have over here, and let's play the animation. On the left, we have the real world. We have a massive unknown population. We draw one sample from it, and this is usually where the story ends. We can't afford to go back and survey 10,000 more people. Watch the bootstrap world appear and the sample, the observed one. But here's the trick. If we pretend that our sample is the population, so this is the sample, which is the population. We then drew new samples from it. This is called the resampling. And you can see this is the resampling. Here's the numbers, the population, 30 numbers. And we just randomly select out of those. First selection, like that. And we can see that there are resampling with replacement. So we have option to select the same number several times, right? So resample, we can see duplicated reasons so far 11, missing recipients so far 15. So we haven't used all the numbers from the sample. And this is very, very unique way for creating those resamples. So see those red numbers, some of them are duplicates because we put each observation back into the pool of the beginning. Some customers appear twice or 3 times in their sample, it's fine. Some of them don't appear at all. This variation mimics the randomness of the real world using only the data we have. And we continue this process. Okay, now what will happen after we finish? Basically, let's go over here and run this one. So let's watch the algorithm run on live on actual revenue data. So on the top left panel, this is our original observed sample. The mean is fixed, you can see it. On the bottom left panel, this shows the current resample. Watch somewhere here, there will be a red bar. So you can see they're appearing very, very tiny amount, but these are appearing. Those are the customers who got picked multiple times. And on the right panel, there is the magic. For every single resample, we calculate the mean and drop it onto this histogram. And we play this animation run and to see how the histogram actually grows. We are building the sampling distribution brick by brick. We aren't using a formula from a textbook, we are brute forcing the laws of probability using our CPU. And the spread of the orange histogram tells us exactly how trustworthy our original number was. If the histogram is very narrow, our estimate is precise. If it is wide, we have high uncertainty. All right, now once we deal that, what we can see over here. Why does this result matter? And look at the comparison. On the left, we have highly skewed sales data, a power law distribution common in retail. And on the right, we look at the confidence interval. The gray shaded area is the classical confidence interval. It forces a symmetric shape around the mean, it assumes the world is symmetric. It is effectively lying to you about the downside risk. And the green dashed lines are the Bootstrap percentile interval. Notice it is asymmetric. It naturally captures the skew of the data. So the Bootstrap tells us what our worst case is actually lower than the classical formula predicted. And by using Bootstrap, we aren't just being more mathy, we are being more honest about risk. To wrap up, here's why the Bootstrap is your best friend. There are no assumptions, it works for skewed data, small samples, and weird distributions. You can bootstrap the median, the correlation, or the difference between the two A/B test groups. The code will be basically the same. And it prevents you from being overconfident. So if you would like, you can try it on your own and see what the confidence interval for the median will be. Is it a wider or shaped differently? And the Bootstrap technique is very critical for pricing models where average revenue can be distorted by one whale customer, right? So this is it. See you in the class.